Now, this expression depends on fx and fy remaining constant. The question is, what if fx and fy are not constant? Over a unit distance, it's possible for our function f of xy to change its behavior drastically. The rate of change in the x direction might be huge. The rate of change in the x direction might change by a huge amount over an interval that large. That might or might not be the case depending on the function, but clearly it may well be the case. So we can't assume that the rate of change remains constant over this large interval, over this large region. So the question, what if fx and fy are not constant? Well, if they aren't, and if the function is reasonably well behaved, now we're going to make the idea of well behaved very rigorous in a little while, but at this point we're just going to say the function doesn't do anything really unpredictable or weird. It simply, if we zoom in on the point x naught, y naught, if we look at smaller and smaller intervals, eventually we can find an interval where, when we zoom in on that region, the changes in fx and fy are not significant. Fx and fy are probably always going to change for most of the functions we'll be looking at, but we zoom in far enough that those changes don't make a whole lot of difference, and then, as you should anticipate, we're going to take the limit as the size of that region approaches 0, and changes in fx and fy are going to simply disappear.